Greetings, madam. Today my slide is about trigonometry in describing real-life engineering. Welcome to Trigo World. Today myself, Sharan Kumar Lek Siva Kumar from class DEP 1A and my cut matrix number 01 DEP 23F1007 and my friend
Elvester Jason Prakash and from DEP 1A and my matrix number is 01 DEP 23F1018.
Introduction to Trigonometry. Let's go. Trigo Basics. Trigonometry, the branch of mathematics concerned with specific functions of angles and their application to calculation. There are six functions of an angle commonly used in trigonometry. Their names and abbreviations are sin, cosine, tangent, cotangent, secant, and cosecant. These six trigonometric functions in relation to a right triangle are displayed in the figure. For example, the triangle contains an angle A and the ratio of the side opposite to A and the side opposite to the right angle, the hypotenuse, is called the sine of A, or sin A. The other trigonometric functions are defined similarly. In right angle triangle, we have the following three sides. Perpendicular, it is the side opposite to the angle. Base, this is the adjacent side to the angle. Hypotenuse, this is the side opposite to the right angle. Components of trigonometry. This is the trigonometry table for the trigonometry. Trigonometry law, sin, cos, tan, cot, sec, and cot. Trigonometry formulas involving Pythagorean identities. Sin squared plus cos squared equals to 1, tan squared plus 1 sec 2. Pythagorean identities is derived by a Pythagorean theorem. A squared plus b squared equals to 3 squared, and cot squared plus 1 equals to cos sec 2. Examples of solving. Trigonometry in engineering. There are four things that trust in structural design analysis: mechanical engineering, electrical engineering, and civil engineering. Introduction to the engineering. Trigonometry is the branch of mathematics that deals with the relationship between the angles and the sides of triangles. It may sound abstract, but it has many practical applications in engineering and architecture, where precise measurements and calculations are essential. In this article, you will learn how trigonometry helps engineers and architects design and build structures, machines, and systems that are safe, efficient, and functional. Structural design and analysis. Another important application of trigonometry is structural design and analysis. Engineers and architects use trigonometry to design and analyze the strength, stability, and aesthetic of structures such as bridges, buildings, dams, towers, and domes. For example, by using the Pythagorean theorem, they can calculate the length of the diagonal of a rectangular beam or the hypotenuse of the right angle triangle. By using trigonometric functions such as sin, cosine, and tangent, they can calculate the angles and forces involved in various shapes and configurations such as trusses, arches, and polygons. Trigonometry also helps engineers and architects create complex and elegant curves and surfaces such as parabolas, ellipses, and spirals. In mechanical engineering, another important application of trigonometry is structural design and design analysis. Engineers and architects use trigonometry to design and analyze the strength, stability, and aesthetic of structures such as bridges, buildings, dams, towers, and domes. For example, by using the mechanical theorem, they can calculate the length of the diagonal and rectangular beam or the hypotenuse of right angle triangle by using trigonometric functions. Electrical engineering. Trigonometry is also essential electric for electrical engineering, which is the branch of engineering that deals with the generation, transmission, and distribution of electricity and electrical signals. Electrical engineers use trigonometry to understand and manipulate the properties and behavior of alternating current, which is the type of current that changes direction and magnitude periodically. For example, by using trigonometric functions and graphs, they can represent and analyze the waveform, amplitude, frequency, and phase of an AC signal, or the power, voltage, and current of an AC circuit. Trigonometry also helps electrical engineers design and control the components that device use produce AC, such as transformers, generators, motors, and oscilloscope. Civil engineering. Trigonometry is also important for civil engineering, which is the branch of engineering that deals with the planning, construction, and maintenance of public works such as roads, railways, bridges, tunnels, airports, and water supply systems. Civil engineers use trigonometry to calculate the slopes, grades, curves, and angles of the roads and railways to ensure that they are safe, smooth, and efficient for transportation. For example, by using trigonometric ratios and functions, they can determine the angle of elevation or depression of a road or railway, or the radius and length of a curve of bend. Trigonometry also helps civil engineers design and manage the drainage, irrigation, and flood control system that involve water flow and pressure. A civil engineer uses nearly every form of math at one point in time to do her job. Algebra is used on a daily basis, and many engineers will have to deal with different equation statics and cellulose occasionally. A good portion of a civil engineer's time is not spent doing math, but when the time comes, civil engineers have to be comfortable with all the forms in math, especially those that deals with physics. Next, my friend Elvester will continue the slide.
Trigonometry in architecture. Scope beyond right angle triangle, basic structure theory, modern architects and technology. Intro of Trigo in architecture. As a branch of mathematics that helps us study the relationship between the different side lengths of a triangle and its constituent angles, trigonometry finds widespread application in the fields of engineering, science, architecture, and even video games. Trigonometry is observed to exist in all the various aspects of geometry, owing to the fact that every straight-sided shape can be conveniently broken down into a collection or a set of triangles, even in the fields of calculus, logarithms, complex numbers, and infinite series. Trigonometry has been observed to have deep set scope beyond right angle triangle. Even though the tenets of trigonometry are traditionally linked with right angle triangles, the scope of the subject is the most certainly not limited to just them. It includes triangles of all shapes and sizes that consist of straight sides and which can be unambiguously classified as a collection or a set of triangles. The laws of trigonometry state that for any arbitrary triangle, if one happens to know at least any three of its stipulated six values of angles and sides, then the remaining three can be deduced with a significant ease. Additionally, the law of sines and the laws of cosines are utilized to determine and compute any angles and side lengths that are categorized as unknown with respect to a particular problem statement. Basic structure theory. In addition to designing the way a structure looks, architects must understand forces and loads that act upon those structures. Vectors, which have starting point, magnitude, and direction, enable you to define those forces and loads. An architect can use trigonometric function to work with vectors and compute loads and forces. For instance, you can use sine and cosine function to determine a vector's components if you express it in terms of the angle it forms relative to an axis. Modern architects and technology. Examine a modern city skyline and you probably see a variety of aesthetically pleasing and sometimes unusual buildings. In addition to trigonometry, architects use calculus, geometry, and other forms of math to design their creations. Structures not only have to be sound but also must satisfy building regulations. Armed with high-speed computers and sophisticated computer-aided design tools, modern architects harness the full power of mathematics. Unlike ancient architectural wizards, today's architects can create virtual models of projects and tweak them as necessary to create fascinating structures that command attention. That's all from us. Thank you very much. See you all. Bye bye.